Number 2, graph the quadrilateral. A, front 1, right 1, up 2. 1, 2. This is A. Point B, front 1, right 2, up 3. 1, 2, 3. This is B. C, back 2. So we're going to go 1, 2. To the right 3. 1, 2, 3. That's C. We didn't go up or down. D, back 2, 1, 2, and then to the right 4, and then we go up 1. Up 1 is gonna be, it's gonna be D over here. So this quadrilateral is gonna be AB, CD, and it's gonna connect that way. AC is going to be here and D is going to be there. Part B, we're asked to determine if this is a parallelogram. So in order for us to determine if it's a parallelogram, I need you to put the vector AB and vector CD in component form and try to see if they're parallel. Terminal minus initial, terminal minus initial, terminal minus initial on all three components. B being the terminal, and A is the initial. On CD, D is the terminal, and as you can see, those two sides are parallel. Now we have to compare BD and AC. And if we put them in component form, you'll find this is -3, 2, -2. If you put AC in component form, this is going to be -3, 2, and -2. Keep in mind you're doing terminal minus initial. These two are parallel, these two are parallel. The quadrilateral is a parallelogram. Part B. Part B, what we have to do is find the area of the parallelogram. I need you to look at two adjacent vectors. We already wrote the vector in component form. So I want you to pick two adjacent vectors. It doesn't matter which two you pick as long as they share the initial point. In this case, I'm going to pick vector AB, which I found it to be 0, 1, 1. And then I want to pick vector AC, which I did it earlier, and I found it to be -3, 2, and -2. The area of the parallelogram is the magnitude of the cross product AB cross AC. Now we have to do the cross product of AB and AC. This is going to be I, J, K. The first vector is 0, 1, 1. The second vector is -3, 2, -2. I'm going to let you expand by changing the J to negative, and then I'll tell you what my answers are. I was multiplied by -2 minus 2. J is going to be multiplied by 3. And then K is multiplied by 3. So the vector is going to look like this. -4I minus 3J plus 3K. I want you to find the magnitude of this vector. To find the magnitude of this vector is going to be the square root of 4 squared plus 3 squared plus 3 squared. 16 plus 9 plus 9, it's going to be the square root of 34. You cannot reduce it, leave it in radical form, you're fine. Part C. Part C, they're asking you if this quadrilateral is a parallelogram. As we can see now, it is a rectangle. I'm going to try to see if it's a rectangle by testing two sides and see if they're perpendicular. It will be good enough if I check one angle. I want to see if vector AB perpendicular to AC and therefore forming a right angle. To do that, I want to do the dot product. If the dot product equal to 0, they are forming a 90-degree angle and it's a rectangle. In this case, as you multiply, 0 times -3 is 0. 1 times 2 is 2. 1 times -2 is -2. As you can see, the dot product is 0. The angle between the two vectors is 90 degrees, and this parallelogram is a rectangle. Now it says, in the case it's not rectangle, how would you find out the angle between those two vectors? In the case when you don't have a rectangle, to find the angle between the two vectors, you do cosine of theta is equal AB dot AC, whatever that number happened to be, over the magnitude of AB times the magnitude of AC, and then you do cosine inverse, and that's how you find the angle between the two vectors.